India's vast coastline, the Indian defence industry is marching ahead with strength and power, continuously engraving the success story of Make in India. A well-developed ecosystem has created indigenous capabilities in naval systems, aero systems, missile, electronics and land systems, keeping pace with the global trends in war-fighting technologies. Greater emphasis on self-reliance, increased participation of the Indian industry with startups, MSMEs, ordnance factories and PSUs as partners. A robust defence and aerospace industry base has been created by simplification of procedures, new policy for indigenization, innovations for defence excellence, offering government test facilities and proof ranges to industry, dedicated team to facilitate the private industry, encouraging intellectual property culture in defence, defence corridors in Uttar Pradesh and Tamil Nadu, reforms in offset policy. Such initiatives have strengthened the ecosystem and defence manufacturing base of the country, resulting in growing investments, production and exports. And the journey of excellence continues. After the remarkable success of Def Expo 18, Ministry of Defence is ready to showcase the digital transformation of defence at Lucknow, a vibrant manufacturing hub of Uttar Pradesh, focusing on innovation and emerging technologies, bringing in a paradigm shift from conventional to futuristic technologies. A show of India's renewed and strengthened defence and aerospace industry, showing alongside the experience of global defence manufacturers. Come, experience the power of growth and commitment. Def Expo 2020. Explore the world of opportunities.
Hello, good afternoon, namaste. A very warm welcome to yet another series of webinars from NEGD, Digital India and Ministry of Defence. My name is Bhumika Suri and I welcome you on behalf of National E-Governance Division LMS team. I will be the moderator for today's very interesting webinars, which is part of the 6th pre-event webinar series from Defence Expo 2020. These webinars are a collaborative effort of Department of Defence Production, Ministry of Defence and NEGD Digital India team, Ministry of Electronics and IT. As India is emerging as a defense manufacturing hub, this edition of Defence Expo is focused on digital transformation in aerospace and defense sector. Def Expo 2020 will bring the leading technologies in the defense sector under one roof and provide a myriad of opportunities of government, private manufacturers, startups, and the entire space. The event is scheduled from 5th to 8th February 2020 at Lucknow. As we proceed, you will get to hear a lot from our eminent speakers in these webinars. It is my pleasure to begin with this session by introducing Dr. G. Satheesh Reddy, Secretary, Department of Defence R&D and Chairman DRDO, who is joining us from NEGD, New Delhi. He is the main speaker for today's webinar. He will speak on the topic Defence R&D in the Digital Age. Also joining us is Mr. Atul D. Rane, Director DIC, DRDO. He would give us an overview of the webinar topic and a detailed introduction of our speaker today. Before I hand over, I will share some housekeeping rules. As you see on my screen, the duration of this webinar is 1 hour and will conclude at around 4 p.m. Indian Standard Time. All the panelists are requested to disable their microphones and cameras when not in use. There is a chat option on your window. If you have to share some feedback or some audio video problems, please let us know through this option. There is a Q&A section. If you have any questions regarding the content of the webinar for some questions for the speaker of today, please ask your questions only in the Q&A section. The best question for the Q&A would be awarded. There is a poll at the end. Please rate the quality of the poll of the webinar in this poll. Also, there is YouTube live streaming. The webinar is being streamed on YouTube live at the Digital India Learning YouTube channel. We'll share the link shortly. With this, now I hand over to Mr. Rane to introduce the topic and our speaker for today. Over to you, sir.
Good afternoon, everyone. We have with us Dr. G. Satheesh Reddy, presently Secretary, Department of Defence R&D, Chairman DRDO, and Director General, Aeronautical Defence Development Agency, ADA. He has made phenomenal contributions to defence research and development and is renowned for his pioneering contributions to the Indian defence and aerospace sector. A visionary and institution builder, he has led indigenous design, development, and deployment of state-of-the-art mission-critical aerospace technologies and advanced missile systems. These cutting-edge technologies have been a backbone for key strategic programs and other defense applications in India. Dr. Reddy is one of the preeminent aerospace leaders and has significantly contributed in formulation of many national R&D policies for effective development and promoting efficient manufacturing within the country. An outstanding leader, Dr. Reddy has conceived and initiated many flagship defense programs, established world-class R&D facilities, and created young scientist laboratories for futuristic research. He is an electronics and communication engineering graduate from JNTU, Anantapur. He received his MS and PhD degrees from JNTU, Hyderabad. He joined the Defense Research and Development Laboratory in Hyderabad in 1986 and subsequently joined the Research Center Imarat, the brainchild of Dr. Kalam. He has been an integral part of design and development of all missile systems. Dr. Reddy is a chief architect of the advanced missile technologies and smart guided weapons. He spearheaded Mission Shakti, India's first anti-satellite missile test, demonstrating the complex mission and handling capability with high degree of precision. As Director General of Aeronautical Development Agency, he led the final operation clearance of the 4+ generation light combat aircraft, leaving lasting imprint on the Indian defense and aerospace capabilities. He piloted the ballistic missile defense program and successfully demonstrated interception capabilities at high altitudes. Under his guidance, many critical technologies and advanced avionics have been developed, which have resulted in a streak of successful missions of various strategic and tactical missiles. His key technology initiatives led to the successful realization of smart anti-airfield weapon, guided munitions, and precision strike weapons. His persistent R&D contributions have made India self-reliant in missiles and avionics technologies. Due to his significant contributions in the field of technology development and promotion of scientific pursuits, he has been conferred with honorary degrees of Doctor of Science by many leading universities in the country. He is the first Indian recipient of over 100 years to be conferred with the prestigious honorary fellowship and silver medal by the Royal Aeronautical Society, London. He has received numerous awards, including the American Institute of Aeronautics and Astronautics AIAA Missile Systems Award, the National Aeronautical Prize, the National Systems Gold Medal, the National Design Award, the IEI IEEE USA Award for Engineering Excellence, and the Homi J. Baba Gold Medal. These are just a few of the highlights of the awards he has received. His technology has brought a transformative impact on the development of systems for the country, and in particular for the Indian Armed Forces. The topic digital R&D or defense R&D in the digital age is a very self-explanatory topic, and I will leave it to the Secretary of Defense R&D, Dr. Satheesh Reddy, to explain the whole gamut of it to us today. Sir, over to you.
Thank you, Mr. Rane. Very good afternoon. It's nice to interact with all of you. And I welcome you all for the DEF Expo at Lucknow, which will be held in February 5th to 8th, particularly the startups and various industries. You come, showcase your products, you see the products which are being displayed by various other people, and work in synergy with various defense R&D organizations and industries here. Friends, getting into the topic of defense R&D in the digital age, let me first tell you the war scenario, the battlefield scenario has been changing. It has been ever changing. If you look at the weapons, which were actually area weapons, have become targeted weapons. Manned systems have become unmanned systems. The systems which were independent, isolated systems, they have become network-centric systems. So the digitization in the battlefield has already come into existence. All this happens only with the digital systems, digital communication, data communication, and various other things. Today, every individual soldier has the latest electronic processor with him, and digital information communication systems are available with him. So this digital age is in the forefront of the warfare just before the armed personnel. Friends, when you look at it, the scenario, as I was telling you, has been completely changed. The three armed forces, the Army, Air Force, Navy, which are there as three dimensions of warfare. Now, the fourth dimension of warfare, space, has come into picture. Space is playing a major role. And then the fifth dimension of warfare, cyber warfare, also has come into picture. If a country is not having enough strength in these two areas which are added now, the space and cyber, I don't think that country will be able to overpower its adversaries. That is the type of a scenario what is evolving today. If you look at it, before entering into any battlefield or before starting any war, today people start launching the satellites, and then the complete surveillance of the area is done, whether it is electronic intelligence, or communication intelligence, signal intelligence, or image intelligence, whatever you say, these are all actually completely done using the space systems, space-based systems, and then you are able to get every information, the real-time information is passed on. Similarly, cyber has become very important. If a country's assets, which are there, are not cyber protected today, I don't think you will be able to do any good job today. You will be able to protect your systems today in the cyber world today. So these are all playing very important role, which are very, very important and completely in the digital domain. That's how the things are happening. See, when you talk about today, Internet of Things, military Internet of Things has come into the picture, how you operate and how you get into it. When we talk about 1970s, 1980s, that is the time where you didn't have any digital system at all. You were working on analog computers, analog simulations. You were talking about the complete system running on the analog computers, which actually, I remember those days where to make the system stabilized, to give the stable results, these analog computers you have to switch on for days together. So Monday morning you come and switch on, and you are only switching off on the Saturday night. And then Sunday is one day rest and again starts. That's how the analog computers and all that were there. Even onboard computers in those missile days also, most of the things were analog computers which were running. But slowly in the 80s, the scenario has changed. The microprocessors have come into picture. The most of the systems which are there in each and every aircraft, or you talk about a missile system, or any other radar systems and all that, the microprocessors started playing a major role. Whether it is the frequencies of 5 megahertz or 15 megahertz or whatever it is, and onwards, the microprocessors were coming into the picture. And slowly, the embedded systems played a major role. And if you take a system, every system used to have a number of processors within that. As a navigation engineer, when I look at myself, in the 1990s or later 1990 itself, one navigation system what we have developed had about 14 to 15 microprocessors parallelly working, communicating with each other, information exchange, varieties of information protocols, varieties of communication channels, whether you are talking about RS-422, RS-485, or you are talking about interprocessor communication, you are talking about 1553, whatnot, many things which were there running parallelly. And the frequencies and speeds were also increased. And talk about the aircrafts, the fly-by-wire technologies have come into picture. Talk about radars, tremendous change. Signal processing systems, signal processing units, the process running at very high speed, computational powers, you are able to process FIR filters, IIR filters, whatnot in the radars and all that. And talk about mission computers, the control, navigation, guidance, mission sequencing, running in real time at fast rate and very complex algorithms and all that have come into picture. And that's how the various systems were evolving. In each and every major system, when you look at it, even the tanks had tremendous amount of computational power, lots of computations and the control systems, guidance system, the gun control system, and the processing systems, even the power electronics also continuously, completely controlled by the microprocessors, microcontrollers, the PLC controls, whatnot, you say, the control actuation systems. And the systems became distributed systems, distributed architecture. If you look at a simple missile, there have been at least 15 to 20 systems distributed, running independently, concurrently, parallelly, and connected, and a lot of information exchange, which actually enabled a lot of flexibility. When you went for distributed systems, a lot of flexibility, ease of operation, and the cabling what is required in the aircraft or in the missile or whatnot, other systems has come down drastically. The weight of the missile, weight of the systems have come down. And so played a major role, all these systems which have come into picture. And that is the first digital area which has come into. In fact, defense has always been in the forefront of any technology coming up. If you look at it, today internet has come out of defense technologies, defense area. If you look at today's popular navigation system, what you use, GPS, Global Positioning System, as a requirement of the defense has come out. So that's how the systems have come out and evolved. Technologies have come from defense systems and defense technologies and frontier systems. Many things have been running. Similarly, afterwards, later, when you look at it, the secure systems have come into picture. The encryptions started playing a major role. The cipher information is one of the important things people started looking at it. Network operations. This is one major thing. I was telling right in the beginning, an isolated or independent system has become a network operating system. Look at the air defense operations, any surface-to-air missiles, which used to be independent battalion or independent launchers, used to be all connected. So you have the complete information of the various aerial targets. Look at one operation center. When you look at it, you have the complete scenario of the border, which are all the aircraft, which are all the targets, which are available. So which launcher, which missile, which system has to handle that. So the complete information is there on the network. The radars are all connected. Information is flowing to the main mission control center, and information is flowing. Look at that. Similarly, the high-performance computing systems have come into picture. The complete CFD analysis you're able to do on that. See, what you used to do by test and get the information, you started doing it by simulation. CFD studies, which were taking earlier months and months together, you started doing that in days and hours. Even internal tests, related things, minimal tests you started doing by actually simulating and doing the CFD studies in high performance computing systems. The software defined radios having to come into picture. The entire radio is in the digital domain. The electronic warfare systems, electronic countermeasures, electronic countermeasures. Particularly today, if you look at electronic warfare systems, which have the ELINT systems, which actually have the jamming systems, which have the comment systems, all in the digital domain, you're trying to have the lots and lots of information working in the digital domain, trying to get the information and disseminate the information, collate the information, and varieties of filters running on the huge amount of data what is coming from these systems. You're trying to filter them and try to use them and that sort of a things. And then the software, related software, the reliability of the software, maintenance of the software, and validity of the software, validation of the software, and the entire knowledge management. These are all the things which actually have come in the second phase of information, with primarily the network operating systems playing a major role, the network-centric system. As I was telling you, network-centric system has become very important. The complete country is connected to the net. If you look at the various armed forces are also there. Entire worldwide, everybody has his own secure network over which the data is continuously transmitting. Data is getting disseminated to various centers, and everybody has the information available in the real time. So that sort of a networks have come into picture and very high rate of information. And I was telling you about the space segment, and that is where the data also was enormous. You're talking about 300, 400 megabits of information. And when you are having a pass of a particular satellite only in about 5 minutes of time, the entire orbit data you're passing on to the ground station. And ground stations related data processing. The ground systems have become very important, collecting the information, disseminating the information, processing the entire ELINT information what collected from the onboard systems is an important thing, and which has evolved in the warfare in a big way. Later, the information warfare, the cyber warfare, the machine learning, the autonomous systems. Look, today, as I was telling you, the manned systems have become unmanned systems. You have complete UAVs, drones, autonomous surface water vehicles, autonomous underwater vehicles, autonomous ground vehicles, unmanned combat aircrafts, even fighter aircrafts which are unmanned. So many systems have come into picture today. They're all reality. And these are all there with the digital systems. A number of process, complete software, autonomous software running, a lot of intelligence is built into it. And people are in their automatic systems and autonomous guidance systems, autonomous navigation tools, navigation aids, whether you're talking about imaging, underwater imaging, and terrain mapping, DESMAC. Talk about many of these things, the autonomous systems, imaging, and number of sensors, multi-sensor data fusion, whether you're talking about IR sensor or CCD, you're talking about electronic imaging systems or many other systems whichever are there, and collate that information, and many things which have come into the picture in the systems which are intelligent systems, autonomous systems, where machine learning and neural network also has been. Train the system, it's automatically able to get itself a lot of information and trying to learn itself and try and automatically work and get the knowledge and try to make it. Then the augmented reality, virtual reality, mixed reality, you are able to use it, you are able to train the people, you are able to train the soldier, you are able to train them on the maintenance, you are able to train them on serviceability and whatnot. So these are all you are able to see in the reality as a virtual reality. Today, if you make an aircraft, you are able to see the entire aircraft and you are able to see through everything and you are able to see each and every part, how you assemble, how you integrate, how you repair what is the maintenance you do, you're able to see in the actual virtual reality, you're able to see. Even the training of a soldier, completely using in virtual reality, you're able to use him how a particular gun, whether AK-47, AK-203, or INSAS, or JVPC, whichever the systems what you have made, you are able to train them using the virtual reality concepts. The complete thing is in the digital domain. That is what has changed the warfare today. And that's how which is continuously getting updated. And today, you see here, you're able to develop your own process. You're talking about FPGAs. There is no system which is there without a field programmable gate array today. And everyone is developing his own ASICs. So that's how the miniaturization has come into picture. The systems which were large, I think, which were 1970s, which were in the size of 10 feet by 10 feet or something like that, today they have become a small system weighing about 1 kg, 2 kg, and sort of things. I remember myself, the first navigation system what we are developing was 50 kg, which we are not able to. That system today has become few grams. It is 150 grams sort of system. The entire avionics is coming out of module. So avionics on a module, navigation on a chip, GPS on a chip. So ASICs you are able to develop. And you're talking about technologies of today. You have come down from what I was talking about 5 megahertz microprocessor, what has been used there. Now you are going to gigahertz. You're talking about technologies of 25 nanometers and then coming down to 10 nanometers and coming further down. That are sort of a technologies which are there and which are getting your own ICs fabricated and you are using those things. And from there, now you are looking for the speeds for the today's world, what we are looking for. If I need to still have my high performance computing system, which can do in, which is being done now in days or hours, I want to do it in seconds and minutes, I need to have quantum computing capabilities. The quantum communications for security communication, entangled systems which are coming into picture. People are working on it, a lot of work going on. As I was talking about you, particularly when we're talking about artificial intelligence today, which is a major role it is playing. I don't think tomorrow you will have any system without an artificial intelligence. And that will play a major role in the warfare. To talk about anything. If you are talking about an imaging system and trying to lock onto a target based on the image, and you will have lots and lots of data, which is there, big data will be available to you. And based on the scenario, what is available, you are able to match the scenario, you are able to predict the scenario, you are able to see the background information, and you are able to accurately see what is your target. So a lot of data processing, big data analytics, which plays an important role. So the moment we say artificial intelligence, the big data is always involved, and you put your intelligence into the system, and system is able to think itself, and system is able to get into all these informations and see. And today, when we talk about aircraft, today we are talking about a stealth aircraft, a 5th generation aircraft, and with many technologies being present in those aircrafts, talking about simulating a stealth. And how do you see what is the radar cross section? What type of, at what frequency bands? When I'm talking about today, frequency bands of right from very low frequency or at least 0.5 megahertz to 18 gigahertz or 40 gigahertz, I need to simulate the whole thing, and I need to see in the system, and I'm going to have a simulation tools for that. This is very important. And drones, UAVs, and particularly working in SWAM mode, SWAM control, hundreds of drones, hundreds of UAVs flying together, doing collectively a job and accurately doing a job. Whatever communication you need to have between them and whatever processing you need to them, whatever miniaturization you need to have. We are talking about micro, nano UAVs. So meaning, the avionics, what you put it on the system should be a few grams. And so that is the miniaturization what you need. The high computational power what you need. If a SWAM need to have the type of artificial intelligence what you need to be there, and you need to incorporate in that, the processing capability you need to put, and then the communication what you need to have, the ground station or various other drones which are there, the SAM control what you need to have that type of communication with those people, with those systems is very important. So today, these are all the new things. Talk about cognitive systems. From you are talking about cognitive SDRs to cognitive systems, cognitive radios, cognitive communication system, cognitive radars, quantum sensors, quantum accelerometers, quantum radars. So these are all the evolving systems which are coming in the systems today. And particularly in asymmetric warfare today, which is playing a very important role today, need to have very highly miniaturized systems consuming low power, and you are able to communicate with your ground stations, you are able to pass on the information. You think you are having a small fly, which are in swarm flies, swarm drones, trying to do a lot of jobs, trying to do a lot of surveillance jobs, trying to pass on a lot of information, trying to collect a lot of voice information, and many things. The type of computational power you require, the type of miniaturization what you require is all feasible out of the changing, continuously evolving digital world today. And particularly today in the cyberspace, which is playing a major role, you need to protect your systems, you need to have your systems the defense of the systems, and at times you may have to have offensive systems, and you need to have cyber ranges, and the type of software, the type of cyber systems what you need to develop are very, very, very important today. When you are talking about today, when a terrorist is walking in a road in a mob, and based on cameras which are kept in the street, you need to identify the person through image processing in real time. It is a challenging task today. And he may be disguising. And so you need to get this information, and you need to pass on to your central computing system, which is there, which is taking in real time, and you're processing that and identifying and tracking the person. These are all the technologies which have come into place, which are evolving a lot, continuously. So this is where your computational powers have to go up today. That is what I was talking about some time back about quantum computing systems. And this communication has to be secure. A secure communication cannot be just on encryption. You may have a key distribution and whatnot and all that. But then trying to have systems like entangled communication system, quantum communication is one important system. And wearable systems, connected warrior. Today we are talking about soldier as a system. Soldier will have everything with him, complete war scenario, what is there in the frontier areas, what is there in the ahead of him, what type of a scenario is there, the image is available. We are talking about foldable displays and his own position systems, his own health monitoring systems, and the entire information of the soldier, independent of him, is being passed on to the main control center, operation center. These are all one of the important features which are coming. People are talking about robotic soldiers today. As I was talking about autonomous vehicles, autonomous ground vehicles, probably will have autonomous tanks, autonomous soldiers with the technology which is evolving, is the area which is coming up. Some have talked about what have been achieved till now, and these are all the areas which are going to come up in a big way in the future. The total blockchain management is another important thing, the data management. So these are all the technologies which are coming. So today, DRDO has taken up many areas of these futuristic areas, trying to work with various academic institutes, various industries, and trying to work in these futuristic areas to ensure that India is going to be in a leading condition in the futuristic technologies. As I was talking about, whether you are talking about cognitive technologies, you are talking about quantum technologies, quantum computer, quantum communication, whatever it is, the directed energy systems, you talk about autonomous systems, the swarm control systems, or talk about advanced materials, the stealth materials, the stealth aircrafts, and many of these areas, whatever I am trying to asymmetric warfare related technologies, the artificial intelligence getting into various systems. These are all the various areas where in the future the DRDO is looking towards, working towards, and trying to work today. We have tied up with many academic institutes, and academic institutes are working on, along with our scientists, on many of these futuristic areas. We had recently a meeting with most of the directors of IITs and NITs and central universities, and a team has been formed looking into the futuristic areas. And also we are trying to simultaneously work with industry, the startups. Many schemes have been brought up to support the industries in a big way. Industry is going to be our partner right from the beginning today. We have brought in a scheme called DCPP, Development Cum Production Partner, who will join right at the beginning of the project as partner and will be working with us. It can be a private industry, even for large systems, even for missiles. And they will be learning automatically, they will be able to produce and deliver the system to the armed forces simultaneously. Similarly, the technology transfers have been made free, open to all the industries. The patents have been made open to the industries. The complete patent portfolio which is there with the DRDO has been made available to the industry, and the industry can choose and they can work with us. And many schemes we have brought in. Today, our complete test facilities are open to the industry today. And we are supporting in a big way the defense industrial corridors, both in UP and Tamil Nadu. We are going to have R&D centers there. Industries can work with us, the startups can work with us, and we support them in a big way. And we have introduced a scheme called Technology Development Fund, where somebody comes out with a solution for a system where there is a problem existing, or a system to be indigenized, or the problems what we are listed out in our website, and we are ready to fund that development there in the industry. This is another thing. And in fact, we are anyway funding lots of research in the academic institutes. Probably we may be funding R&D in the startups also. So we are going to handhold them, we are going to handhold the industry, and we have to work together, the type of systems we are going to come, the systems we have to evolve. See, India has to be a leader in these technologies, meaning the futuristic technologies we need to start working today. And you cannot work in isolation. You need to work with the academic institutes, you need to work with the industry and the research organizations and other research organizations in the country. All have to synergize their efforts and see that down the line, we are able to come out with many more technologies. Particularly some of the things which are coming in the optical domain. Photonics is one more area. The photonics computing capabilities, photonics communications. These are all some of the areas what we are talking about. These areas we need to work together, and the DefExpo will be showcasing, DRDO will be showcasing, many industries will be showcasing their products, and we can have deliberations there, how we can go ahead further, how can we work together, what are the new areas. We are very open for the people to come with new ideas and new systems, new innovations. This is one of the things which we are promoting in a big way. The Ministry of Defense through IDEX or our Technology Development Fund or other contests what we are having regularly, promoting the innovations in the youngsters, and many people are coming forward to work in the defense in a big way. I think with the DefExpo, the type of products what we are showing and the type of discussions what we are doing, it will give a big leap in the defense technologies, and particularly with the theme in the digital domain, the digital age. And today, whatever I'm talking about, defense R&D in the digital age, this will take forward into further new technologies which are emerging today, which are going to come today, and take the systems, the most modern systems we should be able to develop, and making the future very bright for India. Thank you. Thank you very much.
Thank you, Dr. Reddy, for such an informative and educative webinar with us. Now it is time for questions. Dr. Reddy would like to take some questions.
You have some questions. You have to read it. Maybe you can read it. Like to.
Yeah, there is Praveen who says, I would like to know the strategy for cyber security we have included while doing R&D of defense technology equipments. How well are we prepared in terms of cyber security as far as our indigenous systems are concerned?
A good question. As I was telling you, any country, if it has to be really protecting itself, it has to have strong cyber security technologies. The country has been also working in this area. Lots of efforts have gone in, both in the government sector, in the academia, and also in the industry. Lots of technologies have been developed. I don't want to get into this area in details, but I can only say that enormous efforts have gone in, and the cyber security of the country is in a good shape.
We have a question not really related to defense R&D, but maybe towards the DRDO policy. DRDO is developing, this is from Shubha, DRDO developing the supersonic BrahMos missile. What is the next vision of DRDO?
Next vision of DRDO, we are talking about a cruise missile. You should be able to go to higher speeds than this. That's the vision of DRDO.
There is a wonderful question from Prashant Gangale. Sir, selling of arms to other countries doesn't give others knowledge of our defense drawbacks of that particular sole weapon or missile.
I think we should take it positive than looking at the other side of it. We should make others feel that the type of technologies which have gone into it, the technological excellence what we have got into our system by selling to them. The systems what we are making, particularly you are talking about missiles, our missiles are also same world class. We stand in the first 5-6 nations in the world who have produced this class of systems. And the inherent question what in that is that, yes, the message is very clear. We should export our systems in a big way. The systems what we are making, if they are state of the art and having sustained quality and the price is lower, then we will be able to sell the systems. And that is the only way the country become prosperous also. So try to make the systems which are state of the art and we should be able to sell. And we need not be worrying that the people will be knowing about technology. That you can manage how you can do the systems.
How are we placed to develop indigenous development aircraft carriers which run on nuclear energy? Mohit Chandegada.
The aircraft carrier is being built in the country. And you are self-reliant in this area now.
I don't see many questions coming up with respect to
AMCA. There is something question.
I don't see.
There is AMCA just below that.
Just below.
There is an AMCA. Recently,
a scaled model of Surya missile was shown by DRDO in an exhibition. Is there any info from that? Tapas Bhavar. And are we? And what are the challenges we are facing for developing AMCA?
As of now, we don't have any program called Surya. We don't have any program. AMCA is going well. It is the design phase of AMCA is going on very well. And there are no impediments. Lots of technological challenges are there. You know, it is a stealth aircraft. Naturally, a lot of technological challenges will be there, which I'm sure we'll be able to overcome with the design capabilities of the aeronautic engineers what are available in the country.
Sanket Kulkarni, what are DRDO plans in using 5G in image processing application for maybe unmanned robo or drone?
5G, yes, we are will be using for the communication purposes and primarily. For the image processing, what you need is In fact, as I said, the power onboard the system and embedded system, the type of power, multi-core systems and higher computing system, that is what is required and which actually we are incorporating that. But 5G will be playing an important role also in the defense in the coming years.
Deepak Tiwari is firing away questions. We'll take one more from him. With a growing reliance on technology that adversaries are eager to exploit, how do we protect the very freedom and opportunity that technology enables for our country?
Come again? Can you read the question?
With a growing reliance on technology that adversaries are eager to exploit, how are we protecting the very freedom that the technologies offer us?
Oh, this is an important question. We need to actually play a very crucial role and careful role in using the technologies and ensuring that the technologies will not be vulnerable to the outsiders, and that protection mechanisms need to be taken care, and all those measures have been taken care while designing the systems, while developing the software, and complete the protocol what you're developing, all that are being put in place.
I'm looking for actually questions of, as you told, our soldiers are being trained using VR, AR, and mixed reality. Do soldiers face any problem only being trained using virtual reality? What if they tend to lack the skills to face the challenges?
A good question. It is not that only using virtual reality you will be training the soldiers. You spend, instead of actually spending the real hardware and using, you spend most of the time on this. And actual real hardware also you will have some amount of training. So the mixture of it makes him a real expert in that system.
S. Subramaniam. I'm sorry, I'm not pronouncing your first name. Sir, Sachitan Subramaniam. What are the recent skill development plans with respect to nano and MEMS for indigenized manufacturing?
Oh, good question. This is one of the things. We have been talking to many academic institutes on these areas for the skill development and development of the manpower. Not only under MEMS and NEMS, let me tell you about talking about cyber warfare. We have got a couple of courses introduced. Some of the institutes with our reference and with our persuasion, they have introduced MTech courses today in cyber technologies. We are getting courses introduced in the quantum technologies. And similarly, NEMS and MEMS, particularly in the Indian Institute of Sciences, these courses are there and departments are working on it. And we have also established facilities and labs to work on this MEMS and NEMS area. And particularly, we are taking a lot of these people who have studied these courses on internship and giving training in the places where we are designing and trying to develop the systems.
Shubha, I think we took a question from earlier. How do you look at DRDO's role in shaping India as a leading defense power? What are the challenges that may need to be overcome in the future? What is the future of these programs?
Very good question. See, today, one thing, let me tell you, Shubha, I keep telling that we have been technology followers till yesterday, and that cannot continue. We need to be technology leaders. If we have to be technology leaders, we have to work today on tomorrow's or futuristic technologies today itself. So, good amount of basic research, applied research, and then translational research has to happen in the country. So the academic institutes have to play a major role here. Look at any developed nation, whether it is the United States of America, you're talking about Russia, you're talking about the entire Europe, the academic institutes play a major role where they have basic research is going on in many of the areas, which actually may yield results after 10 years. That's one of the important things. From that basic research, the applied research area, R&D organizations like us, we should take the lead and come to prototyping things with the translational research. And industry has to play a major role taking this prototype in producing the systems. So all the three have to work synergetically. Of course, industry also has to do some amount of research in the niche areas of technology, innovations, and come out with innovative products is another important thing. And if these three play the roles the way I defined, I think in 10 years, definitely India will be a very powerful nation in all these technologies.
I'm taking a question from the YouTube live chat. This is one Ashwin M. He wants to know, in the US, you can see every service having its own R&D division, like Air Force Research Laboratory. Why don't we go ahead in that direction to bridge the gap between services and civilian R&D like DRDO?
One thing is not civilian R&D in DRDO, let me tell you, that is one thing. But the point what you have said is a valid point. And I think instead of calling it as Air Force laboratories or naval laboratories or army laboratories, we have the laboratories here in the country which are working exclusively for these departments. Today, if you look at it for the naval sciences and naval requirements, today you have a laboratory in Cochin, which is NPOL, completely dedicated for Navy. Similarly, you have a laboratory in NSTL, which is again completely working for Navy. You have another laboratory in NMRL in Mumbai, which is working for the complete naval requirements. Similarly, if talk of anything air power related, whether ADA is completely for that, we are talking about ADU laboratory in Bangalore, or talking about GTRE, these are all completely for laboratories for that particular application. Yes, there are some laboratories where the technologies are common, whether you're using for a ground application or for air application. Those laboratories, instead of duplicating the work, they are able to work together for these services. And in fact, we have a large number of service personnel working in our laboratories with their respective projects. We have more than about 500 signed armored personnel working in the laboratories for their own specific applications. I think what you said is a right point, and that is being implemented in this way here in this country.
There was a question from Gopi Krishna. Is India geared up for digital security?
As I think I answered this question, a lot of work is going on in the country, a lot of work has happened, and we have taken up this job very seriously. A lot of industries are also coming up, a lot of academic institutes are working on this. As I was mentioning, sometimes a lot of courses have been brought in the academic institutes here in this area. And so with this, I'm sure that the country is geared up to take the challenges in the digital domain.
I think we have some more time. It's up to Bhavna to tell us. We have about 3-4 minutes left. What are the challenges that need to be overcome by DRDO?
Good question. There are how you parallelly work on today's system, today's developments, and today what the armed forces need. And how do you work on the futuristic systems, and how do you parallelly able to carry on both the systems, and how you are able to bring academic institutes to the level what you are seeking, to the plane what you are looking for, and also making the industry come up to your level, taking a load from you, maximum load from you, and see that these systems are able to work together with you and take maximum load from you suddenly. And then also, how do you get the most modern tools into your system and make your system very efficient? And you are able to do the systems fast. You are able to do in well within the time. These are the challenges what today DRDO has.
We'll take one last question from HAL. What is the roadmap for DRDO technologies?
A very clear roadmap has been laid. Number of technologies have been identified. And as I said, along with the academic institutes and researchers in the country, we are still working on that to update this, the roadmap very clearly. There is an LTI-PP of the armed forces, and which actually give the roadmap for the armed forces technology, what they're looking for. With in consonance with that, we have a LTT-PP, and that, and also the roadmap of technologies what you need to develop have been very clearly laid for the next 5 years and 10 years for the laboratories, so that you have research and development together going on simultaneously. At least 25 to 30% of our resources we want to allocate for the future technologies. And that roadmap and the technologies have been very clearly worked out and being updated now along with academic institutes.
There was a corollary to his question and a few other questions also. How will PSUs and DRDO synergize?
Oh, PSUs are basically the production agencies, the government production agencies, and they work with the DRDO. They join the development phase and take on the production after that. And the DRDO and PSUs continuously work together in a synergy for updating the products and upgrading the products, and for all other service and maintenance related problems also. In fact, public sector units are also have taken up on their own some developmental activities. Like today, HL does manufacture, develop helicopters, which actually DRDO doesn't do. So that sort of a complementing roles also have been playing between PSUs and DRDO.
I think we'll take the last question. This is obviously very interesting. Do we have an MTech in defense? A master's in technology?
There's a master's course which is there in DIAT Pune. We have a university called DIAT in Pune, where the master courses are offered there in that university. Both service personnel, scientists, and otherwise also civilian students also take up the course there, and lots of programs are happening there. And also, as I was talking about many other courses today, like cyber technologies, cyber security area, master courses are available in a couple of NITs today. And those also are straightaway usable for armed forces, for military and defense purposes. These are some of the courses which are available. And we are also thinking of bringing up some other courses like quantum technologies and all also into the MTech courses at a couple of IITs and our own institute also. Thank you.
Thank you very much.
Thank you, Dr. Reddy, for answering so many questions. I'm sure our participants are thrilled and very encouraged. We have a poll on our screens, and I would request all the participants to please rate the poll. With this, I transfer to Brigadier Suresh Pillai for a few words before we conclude.
I take this opportunity to thank Dr. Satheesh Reddy, Chairman, Department of Defence R&D, Secretary, Department of Defence R&D, and Chairman, DRDO, for the conduct of the first webinar session on Defence R&D in the digital age, in which he dwelled upon very significant areas of technological development. The session was interactive and generated interest in the digital development in the defense R&D. I also thank all the participants for their active involvement in the webinar. There is an attractive prize for the best query, which will be adjudged by a panel and will be announced in the next webinar. The next webinar is scheduled on 18th December 2019 at 3 p.m. Indian Standard Time, 9:30 a.m. GMT, on Digital Transformation of Defense by Sri Toby Simon, Founder and President, Synergy Foundation. Jai Hind.
Please note that this session is also available on the Digital India YouTube Learning channel. You can watch this whole webinar and all our previous and upcoming webinars on this YouTube channel. With this, I also take an opportunity to give you a tour of the Defence Expo website and the registration process. Now, I hope you see on my screen, this is the website for Defence Expo. Here is the webinar section. The webinar schedule is given here, and the biodata of the speakers, upcoming speakers, would be available here. For registration, please click on the webinar links. When you open this, you will have a schedule of all the webinars, the timings, the dates, and the topics of these webinars. Please click on the link available here for all the upcoming webinars, and you'll be registered. You'll receive an email after the registration. Now, before we end, I take this opportunity to thank the leadership without whom this initiative wouldn't have been possible. Shri Subhash Chandra, Secretary, Defense Production; Shri Barun Mitra, Special Secretary, Defense Production; Dr. Amit Sahai, Joint Secretary Personnel and Coordination, Mr. Abhishek Singh, President and Chief Executive Officer, National E-Governance Division, for providing such an encouraging and supporting environment to us. Brigadier K. Suresh Pillai, Captain Roy Joseph, and Captain Nagesh from Department of Defense Production. And last but not the least, NEGD LMS team for making this webinar such a success. Don't forget to tune in for our next webinar on 18th December this year. The winner of the best question will be announced in the next webinar. With this, we conclude for today. Hope you had an enjoyable session. Happy learning. Jai Hind.